Hello, this is Zekushon from Twitter. Well, not Zekushon, but you guys know already. Today we're going to talk about PS4 keys, the ones that are on the Wiki. You can find them on the PS Dev Wiki on the section for PS4. Let's talk about the first two key sets. The first one is the static key slots, and the second one is the portability or encodec keys. Um, the static key slots. First let me start by saying that user FlatZ has released a method of getting these keys from the console. I tried this on 7.55 and was able to get both. So you can see here the static key slots. So these are used for the purpose of mostly it's save data and the trophies and file systems of the package. Mostly PFS stuff, and also some VTRM stuff for validating the hashes of things used on PSN and all that, but we don't know what's in there in here. So these values, we don't know what they mean, most of them, and we know that they are static, so they don't change across 5.05 and from two different consoles. So we know they are static, but we don't know anything about them. These are a lot more important. They are the encodec keys. They are used to decrypt blobs that are present on the kernel. And the blobs that are present on shell core. So to find these blobs, you also need to reverse engineer either the kernel or the shell core, and you will be able to find them as well as find the IV, because the IV is not present here. It's in a separate place. So you need to first reverse engineer either the kernel or the shell core. For example, on 9.00 or 7.55, it doesn't matter because Sony never changed the blobs. They are always the same. So, for example, you can start here. This one decrypts a section that has the magic PFS SK key sec key. So this is used to generate the keys that will decrypt the PFS file system. So save datas, trophies, stuff related with packages, maybe, I'm not sure, etc, etc. These are keys that I have no idea what they do, because I haven't checked yet what they are used for, but I have checked some already below here. So for example, this here is used to decrypt the keys that I used to decrypt index.dat. So this is in shellcore. So there is a blob, you use this key, and you know that this key is AES 256 CBC, and you use this with the IV that you can find on the shell core by reverse engineering to decrypt the keys that will be used to decrypt index.dat. So these are like key encryption keys. they encrypt keys that are used to encrypt other things. That are these are not the final keys. They are the first layer keys, as I would like to call. So, for example, this one is for the crash repository. So you can use this to decrypt another key that will be used to decrypt the crash dumps. This one, this one is more for decrypting a blob that will contain not the keys but a certain host names. So this one I have no idea. This one, I have no idea either. This one is for SW Wagner and SW Reset. I also don't know what it does. This one is for the cloud save data. So any save data that you save on the cloud, you can decrypt. First you decrypt the blob with this key and the IV, and you find the keys inside, and you can use those keys to decrypt the save data that is saved on the cloud. More. This one is used to decrypt the user token keys. This is used for stuff. It's similar to key flag. So yeah, it's like the PS3, except instead of the token you have the user token. It's similar. This one is for the backup and restore key. So this is obviously not bar keys. These has a meaning. So B backup, A and R restore. They are used to decrypt your generated as I said, these are key encryption keys, so they are used to decrypt a blob that contains the keys to decrypt finally the backup and restore backups that are made with your PS4. More. This one I have no idea what it does. This one decrypts envelopes, so anything that has the extension .env, I believe. So you can find this on your system data partition, if I recall correctly. It's usually just a bunch of XMLs, and it has some information, but I'm not sure what it does exactly. This one is for the secure live dump. So before it had only the crash repo. I believe they updated this to have more security after what failoverflow did. So to get the kernel dumps using the crash method. Then this one is used for age ID. I believe I don't know what it means, to be honest. This one is used for KDF and CDT. I have no idea. This one is for IPME. No idea either. This one is for PFS stuff, so I believe it's for packages. I'm not sure exactly, but it's for packages, I believe. Same, maybe for save data, because it says PFS save data, and these others I have no idea. So continuing, we've shown the two first ones by flat C. This one, I believe it was posted by user Silicon Pina, and it's for the companion app. So the SDK has a file for an executable that installs the companion app to use the on your iPhone, I believe. So I'm not sure. This key, not this key, but the key that SMU actually uses is very important, because the SMU is one of the first things to boot on an AMD processor or APU. So this is the debug key. So if we ever manage to get the correspondent retail key, so we could sign our own SMU firmwares. Maybe it could be possible, and we could use it to do a lot of damage, because SMU is fun stuff to mess with. It's like SAMU, but maybe lower level, maybe more lower level than SAMU, and it's like Syscon, but it's AMD proprietary crap for managing the temperatures and the fan and all that. So moving onwards, we have the Southbridge keys. So these keys are used to decrypt the Southbridge firmware. I have talked about this in the past on PSX Plays. They are used to decrypt the Southbridge master system. So how should I put this? If you have both the cipher and the hasher key, you can make a custom firmware for the PS4 Southbridge, and you can just unlock all the commands. You can send payloads to it if you know what you are doing. You can interact with the APU. You can also interact with Syscon. You can do a lot of fun stuff with this, and you can also break your console, because these keys are very dangerous. Let's move on. So we know that the first Southbridge revision is codenamed Aeolia. Maybe there was another that showed up before Aeolia, because we know that the index is 13 if we check the pubs, and there's an even earlier index which is 1 and 2. It uses a different index for that, and you cannot decrypt that index, but we can decrypt this one. Belize is the second revision, and we also have Baikal and Belize 2. So we have at least 4 revisions, 5 counting with the non-decryptable Aeolia, or maybe it's something else, we don't know. And that's it. So we have here we have the EAP keys. So these keys are how should I explain? Southbridge has 2 chips. One is used for the most lower level stuff, and the other chip is used for more upper level stuff, like connecting with PSN and downloading the updates and putting stuff running in background mode, put stuff running in rest mode, etc., etc. So EAP is in charge of that. EMC is in charge of more lower level stuff. So these keys are, well, the cipher and hasher key only for Aeolia, because with the EMC you can just if you have the cipher and hasher key, you can dump both these keys. And considering we only have the EMC Belize cipher key, if we don't have the hasher key, we cannot hash our own custom firmware to dump the rest of the Belize EAP keys. So moving on, these are the shared keys. These keys are used for generating the HDD shared key that is used to decrypt the HDD user partition, update partition, EAP VSH partition, etc. So these shared keys are very important, but remember that they are used to decrypt most HDDs, but cannot be used to decrypt, I believe it's the Belize 2 HDD or the Baikal HDD. I'm not sure exactly which is which. So these are all used for generating. This one is also used for generating the HDD key. So onwards, we have the syscon keys. These ones are also very important. We have the security ID, which is something that that's used on most Renesas and NEC chips for RL78 and 78K0R. So for example, if you have this security ID, you can access privileged commands, and you can do fun stuff with it, and you can before we didn't have this ID, we couldn't glitch the syscon only once. Now we only need one glitch to make it be able to dump the syscon firmware. So Sony, I believe, patched this on later hardware revisions by releasing a new chip that I have no idea what model it is or what security it has, but it's certainly not Renesas, and it's used a different security. Moving on, we have the syscon keys for DevKit. This is for the full firmware. So if you open up a decrypted pub, you can find the full firmware. It has these names: 4,000, no, 4,000,000 and 1, 4,000,000 and 2, 4,000,000 and 3, and this means blank, base, and system. So with this key, which is CBC 128, and DIV, which is all zeros, you can decrypt the full firmware of syscon. And this is the key that's used for the SMAC. So the SMAC is for validating the firmware. So you can also do fun stuff with this, but it's very, very dangerous, because if you break syscon, it's bad for you. But yes, if you have a dev kit, you can make your own syscon firmware, and you can flash it, and you can pray to God that it works, because if it doesn't work, you have a very expensive paperweight. So yeah, you can use this to make your own syscon firmware. So the retail or the test kit use patch firmware keys. These are the keys. So this one and this IV are used for the patch number 1 and patch number 2. This SMAC is used for both, and this is mostly minor patches, stuff for HDMI and all that stuff. Kernel keys. So you have the kernel magic. This kernel magic is used to identify the place where the IDPS and the PSID is. Well, not the entire IDPS, only partial IDPS, because Sony hid the IDPS and it only shows fully on very prototype consoles, or on the GKIC firmware if it's enabled. So if you have a console with GKIC enabled, if you try to dump kernel, it will show the fully IDPS. So more keys from kernel. So I've talked before about the backup and restore keys. So these are the final keys that you can find in the blob. This is the cipher key, and this is the hasher key. You can forge your own backup and restore backups with it. The default suffix is for need generating. So needs are function names. I have explained this on another tutorial. They're used to create function names. Sony uses this to obfuscate the function generating, and only they have the dictionary with all the function names. These are the crash dump key seeds. They were used by failoverflow to dump kernels, I believe, until 3.50. No, maybe more, maybe until 4.50. So these were the ones used. Then these are the sealed key values. So every time that Sony has a revision of the PFES encryption key or the sealed key values, so it's the one with the magic PFES SK key and SEC key. They add a new blob. So you can see here key set 1, key set 2. So key set 1, I believe it was from 1.00 to 3.70, I believe. Key set 2 was from 4.00 to 4.07, and then you can just go with the .50 increments. So this one is for the 4.50, this one is for the 5.00, this one is for the 5.50, this one is for the 6.00, this one is for the 6.50. Well, you know, it's just .50 increments, and they are used for the PFS stuff. These ones are used to, these are the VTRM cipher keys, so they are used to initialize VTRM, which is a section in the S flash. So if you have any corrupt hashes, you can just use these keys and ask the PS4 nicely to initialize for you. I believe, I'm not sure. Then you have the keystone keys. So these can be used to brute force passcodes. So if you have a keystone of a package, but you don't have that package internal dump, and you want to dump it, you can try to brute force the passcode using these key values. I'm not sure exactly how, but maybe I will make a tutorial on the next video. So onwards to the shellcore keys. So these are keys present in shellcore. We have the debug trophy key, which is used to decrypt debug trophies. The retail trophy key, which is used to decrypt retail trophies. So this key is used to decrypt trophies that have always the same ID. It's usually NPWR 99999, and this one is used to decrypt retail ones. So it has to have different numbers. It's also NPWR, but it changes from 99999 to random numbers. But I'm not sure if it's NPWR or the CUSA, CUSA for these. These keys, RSA package meta, they are used to decrypt the index 3. So for example, on FlatC's PFES package tool, you have a section dedicated to the key 3. So where is the key 3, you put these values. So you put P, you put key. So this is RSA. So you put P, Q, the modulus, which is the public key. The private key is this one. This is all found in shellcore. DP, the key, and key P. So yeah. I also talked about the index dot key. So it's a key decrypted with the encodec. So this is the key, and this is the IV. You know that the flag or the index is 8. Then you have the patch package URL key. So if you want to generate your own patch packages from Sony based on the CUSA ID, you use this key, and you use the CUSA ID as it's called the title ID. Use that as the input, and it should be able to generate the final hash for you. This one is the HID signature verification public key. I have no idea what this is for, so you're on your own trying to find what it is. Onwards to the DualShock 4 keys. The Jedi Master Key, it's this one. You can use it to decrypt DualShock 4 firmwares. So if you have an update and it's encrypted, you can use this key. The IV is 0 and the algo is AES 128 CBC. These ones are also used for DualShock. They are for the the bootloader, the app0, the app1, and the certificate authority used to exchange exchange a handshake with the console, etc. So these are all the keys of the main page, and the talk page has mostly keys from keys and scripts. This one is for decrypting the Aeolia firmware and keeping the header, which will be used after modifying for encrypting if you have the blob, and you can then use it to make a custom firmware with a modified Southbridge custom firmware. Then you have this explains how many key sets Sony has left to use. So it's just a curious fact. This explains about the Southbridge firmware, the key sets that they have. The order of keys in shellcore, it's about the package key 3, so how it shows up. No, this is something else. This is exactly that. These are supposed keys in shellcore that I was looking and I randomly posted on here. This is the database reconstruction magic. So if you write this to a specific place, so it must be this value to a specific place. I don't remember which place. What will happen is that the PS4 will reconstruct the database after a reboot. Then you have the portable keys DOMs. You can find these on kernel and shellcore. These are mostly blobs, so you can see here it's a blob of random garbage, or so it looks. You can see the IV here, so if you grab this blob and you use this IV and you go back and you go to the main page and you go, okay, so this one was, let me check again, the sealed key E. So see if this is a sealed key E. So you go to the portability and connect keys, and you try to find the sealed key E. So it's not here, but it's one of those portable keys. I believe it's 4, but I'm not sure. And you use this key and you use that IV. You can also use this key to check the signature. You go, let me check if the index is the same. To discussion here. Okay, it doesn't say. So if you go here and you use the correct key with this IV, you can decrypt this blob. The signature, you can do it with HMAC. You know, this is an HMAC of SHA 256. So if you use a HMAC key over this blob first before decrypting it, and it matches this signature, you know it's the correct key to use, is the one that's on the wiki, under that section. However, there's a catch. We can only decrypt E blobs. We cannot decrypt I blobs, because we have the external keys. We do not have the internal keys. So what the E stands for is external, and the I stands for internal. Okay, so this is mostly blobs and IVs, nothing important here. See what else. So you can see here sometimes, you can see here the PFS SK key, SEC key. You can see here the magic, and you can see here the keys, which are these ones. You can see that the index is 0. This one is this key. The index is 0x20. This one, the C repo key, the index is 0xc, and so on and so on and so on. So these were mostly dumped before the exploit was released by flatC, because you can just ask the kernel to decrypt them for you, because you have the privilege of doing that. So more keys. Yeah, these are mostly oh, you can see here the envelope keys, and so on and so on. This concludes our talk about the PS4 keys. I hope you guys enjoyed it. If I was a little bit boring, I'm sorry, because well, this is boring talk for people who don't like to hear about keys. But if you like to hear about keys, then this is your video. I hope you enjoyed it, and I will see you on the next video. If you like, please leave a like or subscribe, or if you don't like, so that's also fine. Thank you, and I'll see you.